So the question goes as follows. A freight train, right, which is basically a cargo train, leaves city A and heads for city B, right? And in this case, they're giving us the distance as 44 kilometers. So city B is 44 kilometers away from city A, C. And they give us the speed at which the train moves of 12 kilometers per hour. Right? At that same time, a second train, which is a passenger train, leaves city B and heads for A, right? The two trains barely avoid a collision at a station exactly 12 kilometers from city A, right? At what constant velocity was the passenger train traveling? So this is also a lot of information that we have to decompose and break down, right? So again, we start off with a coordinate axis as we always have to, but not have to, but it's always a good idea to. So there's a city A, a city B along our x-axis. Okay, the distance between them is 44 kilometers. So they're 44 kilometers away from each other. We have our first train, we're going to call train A. Okay, and that train is going towards city B at 12 kilometers per hour. Okay, and at that same time, we have a different train, train B, going towards A at an unknown speed. So I'm just going to call that V, right? So this is what we have. This is the initial condition. Two trains, one has the unknown velocity, the other one is at 12 kilometers per hour, and they're 44 kilometers away from each other. Now, the second phase or the second stage of this equation is that the two trains barely avoid a collision 12 kilometers away from city A, right? So that means at 12 kilometers, they basically met each other, right? So do that, copy and paste that we have this. Okay, so this is phase one and phase two. But at phase two, things have changed a bit. So they are still both moving at constant speeds. However, they are now at a distance that is 12 kilometers. Okay, so I'm just going to do this. Okay. Let me note this down a bit more, so we don't confuse it with the other one. Okay, so this is the second scenario. So at this point in time, they barely avoid collision at a point, this point, and that point is 12 kilometers. Okay. 12 kilometers away from city A. So this is what we have, right? And this is our setup. And they want us to see that speed that the second train was traveling, right? So essentially, the question is asking you, at what speed must the second train be traveling for both trains to meet at 12 kilometers, right? So that is what we have to analyze. And the original distance is 44. So basically, this other distance here is 44 minus 12. 4 minus 12, which is 32. Okay, so at this instance in time, train A has traveled 12 kilometers and train B has traveled 32 kilometers, right? So from this logic, we expect train B to be a faster train than train A, right? Logically, because it has covered more distance in that same time. So what we are going to do in a situation like this is to analyze both trains and find whatever is unknown, right? So I'm going to say train A on this side and train B on the other side. So for train A, we have our velocity as 12 kilometers per hour. Okay, that is our velocity. We have our distance, right? So it has traveled a distance of 12 kilometers as well. We don't know how long it took, right? On the other hand, we have train A, which velocity is unknown. However, when train A has traveled 12 kilometers, train B has traveled 32 kilometers, right? And we also don't know what time. So in train B, we have two unknowns. In train A, we have one unknown. So we can start by using train A, right? Because these two times are going to be equal, right? These two times are going to be equal. Because time is not constrained to any set of axes. Time is just in existence. So the displacement might be different because of the different directions in which they are coming. But time doesn't care about direction. Time is just time. So they should be the same. So the way we are going to do it is by saying, because this is a constant velocity, we can say that velocity is our displacement over time, right? And since we have our velocity and our displacement, we can say time is equal to our displacement over our velocity. This becomes 12 kilometers divided by our velocity of 12 kilometers per hour. Okay? And make sure to keep a note of these units. These units are in kilometers and kilometers per hour, not meters and meters per second, right? So if we calculate this, we get our time to be 1 hour, right? So if you're working without units and you just put the numbers and you got 1 and you forgot it was kilometers per hour and then you wrote 1 second, you should stop immediately and ask yourself, can a train travel 12 kilometers in 1 second? That is physically impossible, right? Even sound can't travel that fast. Even a plane can't travel that fast. So make sure while you are doing your workings, your reason or the part of your brain that makes sense of things is turned on. So make sure you critique your answers a lot. So we know that it should take 1 hour for this train to reach that point. And in that same 1 hour, the other train has reached 32 kilometers. So we are then going to substitute it into the other train. So T is 1 hour. We can then say V, okay, let's call this VB because this is for train B, is equal to delta XB divided by T. We do not have to put B for T because time is not dependent on whichever train. Time is just time. And this is something new that will help you a lot once you realize for acceleration and for every other mechanics application. Understand that time is not geometric. It just is. Okay, so this is A. So now that we have the time, we can then say VB is equal to that displacement of 2 kilometers divided by 1 hour. So that means VB is just 32 kilometers per hour. So what we've essentially done here is we've used the the given values for our first train to find its one unknown, and then use that one unknown that we found to find the other unknown for our second train. I hope this makes sense, like 100% sense.